Hello and welcome to AE5222, Optimal Control of Dynamical Systems. I'm Professor Kaulagi. Uh, this video is just to give you an idea of the course administration and to explain how things are going to flow over the next 7 weeks or so. Now, for those of you who have never taken a course with me, here's a bit of a brief bio by way of self-introduction. I completed my PhD from Georgia Tech Department of Aerospace Engineering in 2011. I was working as a postdoc for about a year at MIT and then as a researcher at a company called Aurora Flight Sciences for about a year and a half. And the common thread among all of these activities was that I was involved in a lot of research on the control of autonomous vehicles, both autonomous aircraft and autonomous cars. So that's my background where I learned most of my optimal control, and hopefully I'll pass on some of that knowledge to you. As far as the course schedule and administration goes, for the online students, there'll be pre-recorded lectures similar to this video that you're seeing right now, short 10 to 20 minute clips, maybe a little bit longer for more detailed topics, but I'll try to break the content into bite-sized pieces. The classroom lectures, on the other hand, are going to be Mondays and Wednesdays, 3 to 5 p.m., so 2-hour lectures with a break in between. And for those who have taken one or more of my classes in the past, you know that my classes tend to be very interactive, full of discussions. Now, the content between the online and on-campus courses is exactly the same. The only difference is these pre-recorded lectures will break down the content into shorter clips. Now, I've divided the course content into 4 modules as detailed in the course syllabus, which you should have access to on Canvas. And for each of these modules, there'll be 1 homework and 1 take-home exam. So a total of 4 homework assignments and 4 take-home exams. The homework assignments you can work in pairs. So if you're an off-campus student, this is going to be particularly beneficial. So you can partner with a student, hopefully who's on campus, or maybe some off-campus student also will work. But the idea is to get together with somebody else and work through the course content. Now, both the homework and all of the homeworks and all of the exams are going to involve a lot of MATLAB, so that's something you should be prepared for. Now, as far as grading goes, the assigned weight for each assignment is 10% for each homework, 15% for each exam, for a total of 100%. But participation matters. So I've done this in my previous courses, and I will continue to do that in this course, is that if you show a lot of participation both through in-class discussions or Piazza discussions for online students, I do take that into account, and that might count for extra credit, especially when it comes to borderline grades between B and A. As far as office hours goes, for online students, office hours are going to be Tuesdays and Thursdays, 12:30 to 1:30 p.m. via Adobe Connect, so you can talk to me remotely. On-campus office hours, 1:30 to 3:30 p.m. on Tuesdays. So for those students who are registered for the online version but are actually on campus, you can take either one. Either one is fine by me. More importantly than in-person discussions, or at least as important as in-person discussions, Piazza discussions. So every now and again, I'll be posting some questions on Piazza. Other students will post questions, and I expect all of you to participate. And this is a very, very good way to get minor questions resolved, especially to do with coding or minor doubts that you may have, and so on and so forth. So before you come to me with a question or come to anybody with a question, check if your question has already been answered on Piazza, because sometimes with homeworks, people tend to have common doubts. I expect you to participate, so I've made the participation non-anonymous. You cannot post anonymously, but I don't want you to feel embarrassed about posting even the simplest of questions. So feel free to ask whatever you like. It's the participation that matters. And ask questions, offer answers, even if you're not certain that the answers are right. And if questions don't get answered or don't get resolved correctly within 24 hours, I'll answer them myself. The recommended background for this course, so let me talk about a few courses that I expect you to have taken, must have taken some course in differential equations. For example, MA 2051 must have taken some course in matrix analysis and linear algebra. For example, MA 2071 in WPI. And you must have fluency with MATLAB programming. Now, these are the three things that I assume everybody knows, and I'm not going to review at all in this course. So if you struggle, if you have never taken a course in differential equations or linear algebra, or if you have never done MATLAB programming, you might have a lot of trouble in this course. So to be sure whether you have the right background or not, I've put up a very small qualifying quiz on Canvas. So this is not for credit. This is just for you to test for yourself if you're prepared to take this course. And it's very small. It shouldn't take you more than 10 minutes or so. And I would strongly recommend that you take this qualifying quiz. It's up on Canvas, and you can see for yourself if you're prepared for this course. Now, in addition to these basic requirements, it's good for you to have taken some sort of a controls course before. You can live without it if you haven't, but this course will make a lot more sense if you have taken at least an introductory control course, or better still, a linear control course, which is offered in the AE program. If you have taken some sort of a mechanics or a dynamics course, like an intermediate mechanics or a course on dynamics, that'll help a lot, because a lot of the principles of optimal control are actually very similar to the principles of dynamics, as we'll find out, especially to the principle of least action, if you're familiar with that. So that's the recommended background. Now, the textbook, I do require you to purchase a textbook, in the sense that I'm not going to provide very extensive notes, because there are many excellent textbooks. This one of them, Donald Kirk Optimal Control Theory, is probably the easiest one to read, which is why I have recommended this for this course. And also, it's a Dover publication, so it's only $20 or so on Amazon. I will keep assigning readings from this textbook, and I will expect you to fill in gaps in my lecture by reading from this textbook. So I wouldn't consider this textbook as an option. You should really get a hold of it. Now, having said that, this is probably not the only textbook that you might want to consider. If you can't get a hold of this textbook, or if you feel that it's too elementary for you, there are several more options. So what I did was I took a picture of all the relevant optimal control textbooks on my shelf and ranked them from easy to hard. So as you can see, the textbook which I have recommended is this one. Donald Kirk is probably the easiest one to read, but there are several others. You can pick basically any one of these. I'm going to assign readings from this textbook, but if you can map chapters of any other textbook, you're welcome to do that. I'm not going to point out specific problems for you to solve. So so you can choose any textbook. In particular, if you're going to choose a different textbook, I'll ask you to consider this one, Athens and Falk. It's an excellent and seminal work in optimal control. Also, for aerospace engineers, Applied Optimal Control by Bryson Ho is something of a requirement if you're going to do any research in guidance and navigation. So that's that about textbooks. Expectations for you to be able to complete this course, and this is something that you might want to make up a timetable for. Commit at least 15 hours of work per week, including lectures, videos, homework, exams, and everything. Is probably going to take you at least 15 hours, if not more. Try to keep pace with the online videos and so on. Keep participating in classroom discussions and Piazza, and keep asking me questions during my office hours to make sure you're on the right track and so on. And like I mentioned before, there will be some gaps in my lectures and or the lecture notes that I provide. So you'll be expected to fill in these gaps with reading assignments from the textbook.